Hi, we have AP Physics 1 past paper 2025. We are discussing free response question section. In this section, question number 3 carry the 10 points. In this question, students are investing balancing system using the following setup. The students have the spring balance of the negligible mass that is fixed one end to the uniform meter stick. As shown in a fig, the center of the meter stick is attached to the stand on which meter stick can be pivoted. Here it is shown the pivoted from the center. There is a hook of the negligible mass fixed at the top of the blocks of the mass M naught. Here is a hook where that is connected to the M naught. The hook can be attached to the meter stick through the one of the small hole in a meter stick. These are the small holes that indicate the 60, 70, 80, 90 as shown in a fig. Students don't have the direct way to measure the mass of the block. The block cannot be attached to the spring scale. Okay, it's mean the block has to attach to this end and we have to push the spring mass system from here. So there is a torque inside kind of the torque experiment, like this end is pushing here downward and this side is pushing upward. The students are asked to measure the measurement that allow the students to create the linear graph whose slope could be used to determine the mass m naught of the block. Okay, the first question describes the experimental procedure to collect the data that would allow the student to measure M naught, include any step necessary to reduce experimental uncertainty. Okay, now the what is should be the procedure? Ensure the meter stick is balanced horizontally as its center, let's say 50 centimeter mark in this case, on the stand, its own weight doesn't create the torque because the pivot point is at the 50 centimeter. It's mean its weight is acting also here. So weight is passing through the pivot point. So torque from the weight should be equal to 0. So because in this case, moment arm is equal to 0 from the weight is passing through the pivot point. Attach the block of mass m0 to the one end of the hole at the known distance d1 from the center pivot. Mean here is the distance from you can measure attach at the different points that can be stand for d1. Okay. Pull down the other side of the meter stick using the spring scale from a fixed distance ds until the stick is perfectly horizontal. Mean when you hook the this mass, this the whole side is goes down. Now you have to pull the spring down. That is the fixed distance that is known as ds. So the again the beam is horizontally balanced when you push the spring down. Now what happened? Record the force Fs as shown in a spring scale. Move the block at least 5 different hold different D1 values. Record the corresponding spring force Fs needed to maintain balance each time. Ensure spring scale is pulled exactly vertically. Repeat the measurement for each hold. Take the average. This average will reduce the uncertainty from the experiment. Okay. Now describe how the data collected in part A could be graphed, how the graph would be analyzed to determine M naught. Now we have to value the as equal to R cross F. We have the ensure the all the forces acting vertically. So angle is 90 degree. So resultant is R into F. So there is the two sides. One side is block, one side is a spring. So block R into F. There is a distance D1. There is a M naught G is the weight of the block. Now the distance of the spring side is ds and the spring force is Fs. The data should be produced straight line through the origin because when d is equal to 0, force is equal to 0. Theoretically, it is. So Fs y is equal to mx, the line of straight line. So Fs is equal to mgd over mg over ds into d1. So m naught is constant, g is constant, ds is constant. So vertical axis is equal to Fs spring force, horizontal axis is d1, the slope is stand for m naught g by ds. From the slope, we can calculate the m naught. M naught is we place m naught, ds should be moved the other side. So from the graph, we calculate slope, ds is fixed, g is fixed, so we can calculate the value of m naught. Algebraic relation from the torque balance allow m naught determination without direct weighing. That's the key point of the experiment. Now the student have an identical meter stick of the mass m that is now attached to the axle that is fixed to the wall. The stick is free to rotate. Here you can see the meter stick is free to rotate with the negligible friction about the axle. Meter stick is suspended horizontally by the string that is connected to the spring scale of negligible mass. That's the situation. Now that is the axle. The meter stick is horizontally. Here there is a different holes, so we can plug the spring through the string of negligible mass at different holes. So that is the angle theta making with the wall. So the angle theta string makes the meter stick varied by attaching string to one of the peg located along the wall. Mean if we place here, so theta is variable. Theta can be variation from these. L. The student use the spring scale to measure the tension Ft required to hold the meter stick horizontally. Table 1 shown the value of theta and Ft. We have the different angle of theta and different tension force. That force is calculated from the spring scale. Now student correctly determine the relationship between the Ft and Ft is equal to 5 mg over 6 sine theta. The student create the graph with 1 by sine theta plotted on horizontal axis C. Indicate what measured or calculated quantity could be plotted on vertical axis to yield the linear graph whose slope can be used to determine to calculate the experimental value of mass m of the meter stick. Now question is what is at vertical axis. So from the y is equal to mx we have the value of the ft. So we can place ft is equal to 5 mg by 6 1 over sine theta because horizontal axis is 1 over sine theta, so that is the slope of the graph, that is the ft. So we come to know the vertical axis should be ft, horizontal axis 1 over sine theta, and the slope of the graph is 5 mg by 6. On a blank grid provided, create a graph of the quantity indicated in a part C1 that can be used to determine the M naught. Use the table 2 to record the data points or calculated quantities that will plot, calculate, clearly label the vertical axis, including unit as appropriate. Plot the point you record in table 2. So we are provided initially theta and ft. So from theta we can calculate sine theta, and from sine theta we can calculate 1 over sine theta. Ft is a vertical axis and 1 over sine theta is a horizontal axis. These two quantity we use to plot the graph. So draw the straight best fit line for the data graphed in a part C. So that's the graph we have plotted against the given values. So I have to mark the it is passes through the origin as we have concluded in earlier previous case. Thus theoretically we have find that uh, when d is equal to 0, f is equal to 0, so that should be passing through the origin. So that's why I choose the points that pass through the origin. So using the best fit line, draw in the part C3, calculate the experimental value of the mass m of the meter stick. We first of all calculate the slope of the graph. Slope is delta y over delta x from two different points on the long y axis, and the same from you can see this is the points we have selected, then and last one is this one. So these 2 points are used to measure like that. So uh, difference of the delta y over delta x is equal to 7.88 Newton. From C1, we have the value of the slope formula. From we calculate the slope is 5 mg by 6. So we can calculate the value of m. We have the value of slope, value of g, 5 over 6 is constant. So m is equal to 0.97 kg, almost you can say 1 kg. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, Allah.